Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss a concept of constant efficiency curve of centrifugal pump. So this is the part of a characteristics curves of centrifugal pump. We have discussed already two types of characteristics curves. So it is divided into three types actually, we know that. Actually this is the part of characteristics curve of, this is characteristics curves of centrifugal pump. So this is actually divided into three types, three categories are there. The first one is we have seen, that is main characteristics curve of centrifugal pump, and the second one is the first one. Second one is the operating characteristics curve. Operating characteristics curve of centrifugal pump. And this is the third one, that is called constant efficiency curve. Constant efficiency curve of centrifugal pump. So already we have discussed the first one, like main characteristics completed, operating characteristics curve also completed, and the third one, this is the constant efficiency curve. So this curve also, it is called as the iso efficiency curve. This is also called as iso efficiency curve. Iso efficiency curve, or also called as Musel's curve. Okay, these are the names are there, or you can say this is Musel curve. So in this curve, if you see that two types of graphs are there. In this graph, we have different parameters, and the correlation between different parameters are there. So while discussed about the main characteristics curve and operating characteristics curve, we have different constants are there, and here we'll have different constant or different parameters need to be considered here. So here you can see that we have two diagrams are there. The first one is the diagram A, or the figure A is the figure A. The figure A indicates that the correlation between, or the graph between H versus Q. That means head versus Q. So Q, you know that is discharge. So which is represented by meter cube per second, or we can take as liter per second. And this is our head, which is denoted by M. Efficiency is in terms of percentage, and the symbol is eta. And here discharge also the same thing. We can write meter cube per second, or we can write this is liter per second. Any one we can give it. So in the figure A, its relation is between the head versus discharge. So this head versus discharge already I have told you in the operating characteristics curves, how it will be, how this curve will be, why this curve is structured like this. Okay, now this curves represents, in this curves actually, it represents the comparison like between head and Q, and with different speeds. So now here the speed are taken different. So speeds are vary. That means different speeds are taken for, again, as per the different speeds we are having different heads also. So here speed is not constant. Okay, only diameter we can consider as a constant. And as I told you that we need to find out the constant efficiency curve. So let's see how to find out. So first diagram, let me draw it here again, so that we'll have some idea how to draw it. So first one, I'll draw a diagram between like head and discharge. So this is our x-axis, and this is our y-axis. In the y-axis we have H, and x-axis we have Q. And the Q, let's consider this is meter cube per second, and this one we can consider this is meter. So the correlation between this head and discharge, the plot will be like, as I told you, different curves are there. Okay, now suppose this is the first curve for the speed N4. This is the second curve for the speed n3, and this is the third curve for the speed n2, and this is the last curve which is speed for the n1. That means different speeds are taken here: 100 rpm, 200 rpm, 300 rpm, 400 rpm, like that different speed we have taken, and based on the different speed we got different head value. Now though we can say this is our origin point is there, so from this origin point the values are started. Similarly, I'll take another one diagram, and that diagram indicates the correlation between efficiency and discharge. Okay, one thing I forgot to inform you, that why these curves like this. You can see this is the discharge value. Okay, and head points are started away from the origin, because we know that when the fluid is flowing, suppose this is a centrifugal pump is there, and how the centrifugal pump is working. So we know that this is our suction pipe and this is our delivery pipe. So delivery pipe will be have some fixed destination, that up to this height or up to this place we need to deliver the fluid or liquid. Okay, whether it may be a water or it may be a chemically any liquids will be there. So this is our suppose reservoir. Okay, that is called actually sump. That is called sump, and this is our pump is there. So in the pump we know that number of blades are like attached in this. So this is our pump, and the pump is like this is the top portion will be casing, and inside that impeller is there, and this is our suction pipe. Okay, and this is our delivery pipe, and this is our destination at which we need to deliver the liquid. So what will happen? So the water will be started lifted from the suction pipe, then it will be transferred to this impeller. From the impeller it will go to the delivery pipe, and the water will be delivered. So what is delivered means, see, now this is our delivery total height. So yeah, so this is our delivery height, that is h. So now if you can see, when the water is delivered, we can close the delivery valve. Here one delivery valve will be there, we can close the delivery valve, and here also one valve will be there, that is suction valve. So when water is delivered, okay, that means no discharge. Okay, if you close the delivery valve only, this is going to 0. That means the discharge is going to 0 when the water reached the maximum height or maximum head. That's why the discharge 0 when it is reached to the maximum height. And this is for n1, n2, different speeds are there. Okay, and now see, when this delivery pipe is closed, then our discharge reached or water reached or liquid reached at the maximum height, and that is our this one. As the discharge increases, like the flow rate increases, okay, this is the flow rate also. So the flow rate increases, you can see our head value decreased. Why the head value decreased? As I told you previously also, there is some losses will be there. Due to the losses, it will be started reducing. Okay, so maximum head can be reached at the 0 delivery point, 0 discharge value. So this is the basic concept. Okay, now we'll go for the next one. So the next diagram is, that is the plot between the efficiency and the discharge. So the same thing, discharge we can write, this is meter cube per second, or if you want to write liter per second also, we can mark it. Okay, and here the correlation, like how this will be, actually the efficiency point supposed to be started from the origin, but we'll take little bit height here, and here also we'll take for different speed. This is the first one, suppose. Okay, and this is the second one or second speed, and this is the third one, third speed, and this is the fourth one, n4. So we have different speed value we have taken, like different speed we are having different efficiencies are there. Okay, so now this one, same thing, I'll mark it here, like this is n4, this is n3, this is n2, and this is n1. Okay, and this is our efficiency. So the value also, if you want to give, we can give the value like discharge value. If you want to give, suppose let me give here 0, as I told you, this is 0 point, original point here. So from here we can start, like this is the discharge, 10, 20, 30, 40, okay, 50, 60, 70, 80, like that. Similarly, in the y-axis also we'll have the efficiency, like suppose 10% efficiency, then 30% efficiency, 50% efficiency, then 70% efficiency, this is 90, and 100 you can give it here, or else we can write 10, 20, 30, 40, all these things we can write sequentially also. So how this got efficiency curve like this? Because we know that, okay, for the figure B, it indicates that efficiency versus discharge. So here the efficiency, we know that output power by input power. So output power is nothing but how much output, like how much power we are how much power is generated by the pump at the finally, and input is how much power we are supplying to the input at the input condition of the pump, that means shaft power. Okay, so we have seen previously that if your discharge is 0, okay, if suppose your discharge value, like if your discharge is 0, suppose if your discharge equal to 0, then we can write our output power also 0. If there is no discharge, there is no output power generated. Okay, but discharge increased, our output power also increase, but it will be not same for the input power. So when the discharge is 0, okay, your input power will have some quantity of power is required. Suppose from 5 kilowatt or some 10 kilowatt, 1 kilowatt power is required, okay, to overcome the mechanical losses. Some like mechanical losses will be there already initially. So to overcome that one, we require some input power. So, but after that, if your discharge is increased, your input power also increase. That means, see how much discharge, in the sense how much mass flow rate of like how much mass of water is flowing through the pipe. So to flow more water, to discharge more water, obviously require more power in that. Okay, this is a very simple concept. But here if you see our efficiency will be output power is, suppose at 0 discharge. At 0 discharge, what output is how much? 0. But at the 0 discharge, our output value, some value is required. Okay, so we'll get efficiency equal to 0. That means we can write Q is 0, in the sense our efficiency will be 0. The same thing I told you, that efficiency need to be started from origin point, but we have taken some distance from here. So this is our concept. Now the next thing is we need to consider a constant efficiency line. Yeah, the constant efficiency line, we need to consider any percent. If you can consider 30% of efficiency, you can consider a 40% efficiency, we can consider a 50% efficiency. So let me consider a line, suppose here, this is our 40%, suppose. So at this 40%, this line, let me consider this line, and this line is called constant efficiency line. This is not constant efficiency curve. This is only constant efficiency line, what you can see here. Okay, so from these will generate the constant efficiency curve. Okay, now you can see this line, when it is where it meets the curves, different speeds. Okay, we can mark it A, B, C, D. All these points we can mark it. Okay, now what we'll do, we'll just plot some vertical lines. Okay, we'll just draw some vertical lines from each point, from each of the speed lines. So these are the different speeds, correct? Now if you want to find out for this particular speed what is the discharge and how much efficiency and how much head, now you can identify. So the head we are going to identify for different speeds and efficiency. Now suppose this is the discharge value is there. So different discharge values are there. You can see this is suppose 8 meter cube or 5 meter cube per second, this 10 meter cube per second, and this is 15 meter cube per second, this 20 meter cube per second. But in the same efficiency line, in the same efficiency we are generated, but different speeds are there. Okay, so that we need to keep in mind. So similarly here also the same efficiency was generated even at a different discharge value. At the different discharge value we have generated this one, but here the head maybe differs. That we'll see here. Okay, so we'll do one thing. Let's plot this line. The first N1 line I'll touch to the N1, first A point. So I'll mark it here A. Similarly, the B point I'll just draw to the next N2 point, that is B point. Similarly, the C, the third one, so I'll join up to the third speed. The line is not coming straight, so we need to be careful. Okay, and here this is the fourth one, that is N4 speed. So I'll join up to the N4. So I can join this. Okay, this is the first, is this side. Again, in this side also we need to join all these points. As this is the N1. N1 is, so we need to join up to N1 here. So I hope it will be like this. Similarly, N2 is there, so we can join up to N2. And this is N3. So we'll join this line up to N3. Okay, and finally this is our N4 point. So N4 point, this one. So now you see we got some points here. We got all these some points from each of the speed lines. So now what we'll do, we'll just join all these points and it'll make a form of curve. Okay, now see, if I'll just join this, okay, so it likes a forming of curves, and this curve formed, the curve which is formed here, that curve is called constant efficiency. This is called constant efficiency curve. Okay, this curve is called constant efficiency curve. At which efficiency, like at what percent we have taken this one? This is the curve which is generated at suppose 40%. 40% efficiency. This is here, we can see that efficiency line we have taken here 40%. So the same things we can generate for different efficiency also. If you take the next one, suppose 60, I'll take here 60 here. So this is efficiency, constant efficiency line 60. Again, we need to plot new we need to see if this is the point. So we need to touch the, I'll just give you the example now where it is touching. See, this is the touching point. That means slowly that point will be reduced and we'll get a forms like this. Let me show you here. The curves will be like this. Again, the next one we can get like this. Again, the next one will get like this. That means different curves are formed based on the efficiency line. Now you can see if the efficiency lines are increasing, here the curves values are decreasing. The decreasing in the sense, this from this curve actually we can find out the head. What is the meaning of this? We can generate the at this point. If you see, now I told you what the constant efficiency line, that is 40% efficiency. Head, how much? This is the head. So here we can give 10 meter, 20 meter, 30 meter, 40 meter, 50 meter, 60 meter. All this value we can give. Now this is 40%. Now let me write at efficiency 40%. The discharge value we can get it here. Like suppose it may be suppose 40 liter per second. Okay. This is 40 meter cube per second, let's write. And here head is how much? So head we got, this is 10 meter. Okay, at speed, again we need to identify the speed. Suppose speed is 100 rpm. Okay, now at the same constant efficiency line, okay, we got different speed for this B point. So different speed is N2 is suppose here 200 rpm. Now for the 200 rpm, what is the H value is there? Now this one, the H value. Now how much is there? Suppose here 20, here 30 we got, suppose. Now head here 30, this is 20, let me write. Yeah, now here if you see the B point, the discharge is increased here. Okay, so discharge value here 50 meter cube per second. But what is the efficiency curve is there? Efficiency value, that is also 40%. You see the changes are there. How much? What are the changes are there? So here also I can give a statement. When the speed increased, our head also increasing. You can see from this graph. Okay, and along with that also I can say our discharge also increasing, because we know some correlations like Q is directly proportional to N, and also the H is head directly proportional to N square. All this speed, I'm showing the speed correlations, and the power is correlations with NQ. These things already we discussed in our previous lectures. And I hope you understand this lecture, because these diagrams are taken at different speeds. Different speeds are there. And why this is required? The point is why you should discuss this and why it is required for us. The basic or the fundamental things I can say, when you select the pump, that means pump selection. by selecting the pump at what head, how much efficiency you'll get, and what should be its head discharge value. So all these things we can identify from that. Even if you want to test the pump with a variable speed, so for the variable speed of pump we can consider this also. Even we can see that relation between this efficiency and discharge and head and discharge. So whatever we want to do, we can do different kind of test also. So I hope you understand, and still if anything is missing, you can give a comment, or you can, if you are having any kind of doubt and query regarding this, you can give a comment on the comment box. Thank you all.